Okay, so you guys have a chart that you guys are working on filling in, and I just wanted to make a short, quick video on how to fill in this chart. So one of the things that you'll see in the actual chart is the name of different polygons. Now, what's a polygon? A polygon is going to be a enclosed shape. So this here is an example of a polygon. Let me show you what the chart looks like so we can see what it is we're working with here. So here's the name of the polygon. The name of the polygon is going to depend on the number of sides. So you guys need to look at the number of sides and figure out how you would name that polygon. Figure out how many angles do each of these have. Okay? So let me show you what that means. I'm going to count these angles. I have 1, 2, 3, 4, 5, 6 angles. Okay, so that's one of the things that you have to find. In this example, there are 6. So the 6-sided figure, or a 6-angled figure, we know this is called a hexagon. So you can fill that in on your chart, but that's going to be a hexagon. The number of angles is going to be 6. So then it says the number of triangles. So let's figure out what that necessarily means. Okay. Now that's something that we're going to have to draw in. And what you want to do is you want to break apart your shape into triangles. Why? Because we know that the sum of the angles in a triangle, so here's a side note, let's draw a triangle. Here's a triangle. If we have angle 1, angle 2, and angle 3, we know that the sum of these 3 angles, if I add up those 3 angles, it has to be 180 degrees. Okay? So if I can break this apart into a bunch of triangles, then I can figure out the total number of angles on this, in this shape. So we are going to break it apart. So start with one of the vertices and just draw from that vertex to all the other vertices here. So if I were to connect it to the one right next to it, that's not going to create a triangle. This, however, creates a triangle. If I connect from there to here, that creates another triangle. Now the thing is you want to figure out how many triangles can you break this up into, where you only have triangles, and the triangles can't cross one another. So we don't want any of these lines to cross one another. Here's why. I can see that I have 4 triangles here. So the number of triangles is 4. Now I'm going to try to color coordinate this for you so you can see. In the first triangle, we have this angle, and this angle. In the next triangle, we have these 3 angles. Then we move down to the third triangle, where we have those 3 angles. And last but not least, we have this 4th triangle, which is made up of these 3 triangles, or those 3 angles, sorry. So what does that tell us? The green, the red, the blue, the pink, all those angles, so the green angles have to add up to 180. So we have 180 with those ones. The red have to add up to 180 because we know the sum of the angles in a triangle are 180. We know the blue adds up to 180. And the pink is going to add up to 180. So then what you can do is we know that the sum is going to be, now if you look at what we were looking at overall, this hexagon is made up of 6 angles. And you can see that all of 6 angles have been completely highlighted. So if I add up this 180, and this 180, and this 180, and this 180, I have a total of 720 degrees. That means the interior angles have to add up to 720 degrees. I also know I could have found that by just doing 4 times 180. That's just your basic math. Instead of adding 4 of them together, you can multiply 4 times 180 and still get the 720 degrees. Now, what is a regular polygon? The regular polygon says that all angles have to be congruent. Okay, so for it to be a regular polygon, this says that all sides and angles must be congruent. So then, if all 6 of these angles, because there are 6 angles here, right, we have 1, 2, 3, 4, 5, 6. If all 6 of those angles had to be the same, I could take 720, divide by 6 evenly, and each angle would have to be 120 degrees. So that's how you're going to fill out each of your rows in your table here. Now, you're not going to need to show as much work. You're not going to have to color coordinate everything. You're going to be able to break up these apart in triangles, figure out the number of triangles, which will then figure out the sum of the interior of the angles. N is the number of angles. How many angles? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 of them. Okay. Name the polygon. So it's a lot less work. Once you get down, you should be starting to develop a pattern. Okay. So once you get that pattern, your goal is to figure out what would an n-gon be. An n-gon, we didn't draw it in because it could be any polygon with n angles or n sides. The polygons have the same number of angles as they do sides. So if you have n sides, how could you figure out the number of triangles? How could you then figure out the sum of the interior of angles? So you're trying to come up with a rule for these down here, and that's what we're going to be discussing on Tuesday. So you want to have the whole chart filled out and see if you can develop those rules at the bottom.